Hey guys. So this morning, Dave's EEVblog episode 279 came up on my YouTube feed. I'll have it linked below. If you're just getting started using oscilloscopes, I highly recommend you watch that because he talks about common mistakes that newcomers make when using oscilloscopes, particularly having to do with connecting the scope's ground clip. Because, of course, the ground clip is connected through your probe lead into the oscilloscope and goes through the oscilloscope on most models, on almost every model, goes through the oscilloscope and to mains earth ground. So you can't just go connecting this clip up wherever you want to in a circuit that's already referenced to ground, or you can run into some trouble and either damage the circuit or destroy your probes. Now, while his video was pretty thorough and very informative, there's a bit of a special case that he didn't touch on that I think is worth particular attention because it's not immediately obvious why this would be a problem. On paper, it looks like it should work just fine, and so I think that makes it especially perilous if you're not aware of the potential for hazard here. So here's the scenario. You've got a full wave rectified circuit and you want to look at the output rectified waveform. So you might think, okay, I'll just connect up the scope's probe to my positive DC output over here and connect the ground clip over here to my minus side. And you'd be right, and that'd be just fine for a circuit like this where you've got a transformer that's feeding the input to your rectifier. Because of course the transformer electrically isolates everything on the rectifier side and beyond from your mains input, and so it's perfectly fine to reference any of these points around here to earth. So you could call this ground, you could call this down here ground, this input ground. It doesn't matter because there's no electrical connection through here to ground anywhere. Now where you run into problems is in the second scenario down here, where we've just got the mains line voltage feeding directly into the full wave rectifier. So line voltage coming in through the top here and neutral connected around the bottom. Now, in this case, connecting the ground clip to your minus side of your rectifier or anywhere else in this rectifier is going to cause problems. And the reason for that is, at least in the US, and I'm sure this is true in other countries as well, but in the US, neutral and ground are connected inside of the breaker box. So if you look right here, you've got the neutral line comes down, goes into your breaker box, and then it's connected over to ground. And now that ground is going to go up and into your oscilloscope, and then you're going to connect that ground clip over here. And so now look at what you've done. Now you've got a current path that goes from here down through to here. So you've essentially just shorted, you put a dead short across this diode right here. So now you've got 120 volts of potential difference across this right here, going through your probe lead and through this diode right here. And a diode and an oscilloscope probe are not going to be too happy with you putting 120 volts across them. So just to show you what I mean, I've got a little test circuit set up here, and I've got my test lamp fixture right here. Essentially all this is this light bulb is wired up in series with the hot side of these outlets, and that's so that if I'm working on something and I accidentally short out line and neutral inside of device I'm working on, it's not going to be a dead short across mains. It's going to go through the bulb first, and it's just a little safety precaution. So I've got here a power cord hooked in right here, and I've got that power cord running out into this rectifier. Let's see if I can focus in on that. And this, if you're not familiar with these, this is essentially, it's a full wave rectifier. It's essentially the 4 diodes that you saw in the diagram, just put together in one package. So the line and neutral AC are coming into the middle here, and then you've got the positive output over here and the negative output over here. And so what I'm going to do is just to simulate connecting the ground lead of the scope probe to the minus side of this rectifier. I'm going to go ahead and turn this on, and I'm just going to touch the ground to my mains earth ground over here. Okay, so you see when I connect this here, then I'm shorting out half of the full wave rectifier, and there's 120 volts of potential then across this, my oscilloscope ground lead and one of the diodes in this rectifier. And of course I've got the light bulb in series here so that I don't vaporize this little alligator clip or destroy my rectifier bridge. But if I didn't have this bulb here, then instead of it getting hot, this lead would be getting extremely hot very fast, and it wouldn't be a good thing, especially if that was your oscilloscope ground clip, because that'd pretty much be gone instantly. Alright, so just in case that little demo wasn't clear enough, go ahead and show you the real thing. So again, I've got my full wave rectifier, and I'm just going to first take the positive end of my scope probe and connect it to the plus output, and you see that we get half of the wave out, which is what you would expect. And so then you might think, okay, well, to get the full wave rectified output, we'll just take the ground clip and connect that over here to the minus side. And you can probably tell that my emergency light is clicking on. So that's not going to work, and if you try that without your safety lamp in series, you're going to destroy your rectifier and the ground clip, at least, of your oscilloscope probe, maybe cause other damage, I'm not sure. So then how would you go about making this measurement if you want to see the full wave output of this rectifier? Well, one way is that you could unplug your oscilloscope and cover up the ground pin of the plug with some, electrical tape or Kapton tape, and isolate the ground pin from mains ground. That's one way to do it. Another way, and probably the better way to look at this output, would be to set up the poor man's differential probe. And so the way you do that is you take a second channel on your oscilloscope, and you'll connect that channel 2 to the minus output of the rectifier, and I'll go and turn channel 2 on, and so we want to look at the difference between the two now. So we'll go ahead into channel 2's menu and invert it, and then add channel 1 and 2, and I'll turn the original signals off, and there you can see the full wave rectified version of the signal. So thanks for watching that. I hope that helps some of you. Like I said, it's not a very obvious problem unless you're aware of the fact that line and ground are connected in US wiring, and so because of that reason, if you're not aware of that, then it's a really easy way to destroy some oscilloscope probes and rectifier diodes. I myself have done 2 different probes that way. just sure that there had to be something wrong with the circuit or something wrong with a part and not with my method, and not realizing that because of the ground neutral connection, I was shorting out my rectifier by connecting the scope ground. So yeah, just something to keep in mind if you've got a bridge rectifier directly hooked up to mains. Alright, thanks for watching, guys. Bye.